So the first thing that I wanted to talk about today was how graphs are related using translations. And so this goes back to what we talked about. We discussed this way back in chapter 1 when we took like an absolute value or a quadratic and then we started adding things and it moved it right and left and up and down. Do you sort of kind of remember that? Some of you are nodding. So anytime that you take an x value and you replace it with x minus h, what that is going to do to a graph is that is going to shift the graph or move the graph h units to the right. Some things to note about that. One of the things that I told you, and I've said that consistently, is x is a liar. So I want you to notice that it's minus, right? But it's moving it to the right. So if instead it was x plus something, how would that move the graph? To the left. Okay, so I'm going to assume that, I'm not going to write that down, I'm going to assume you know that. Then the second transformation is this plus k right there. And if you see something we already don't notice that yesterday, I had you do some, you just tabled them. That moves a graph k units up. Okay. In addition to that, a negative in front flips the graph in front of the x-axis or over it. That would be the only other transformation. Okay. So really what I want to focus on then is just showing you how you could use, instead of just tabling, you can use the idea of transformations to sketch a graph. So let's take a look at our first example. The question is, I ask you to graph 2 to the x minus 3 plus 1. So first, I'm going to just tell how is it related to 2 to the x. So what is that going to do? Write 3. And then up 1. Okay. So how I would like to handle that then is I would like us to sketch a graph of 2 to the x, because that's going to be way easier to table. And then what we're literally going to do is we're going to shift our points right 3 and up 1. Okay. So let's first graph 2 to the x. If I did 3, let's do 4 points again. What's 2 to the negative 1? Remember, a negative exponent means to do 1 over. Okay. So it'd be 1/2 or 0.5. What's 2 to the 0? Anything to the 0 power is 1. 2 to the first is 2. 2 to the second is 4. I label those points. So here's negative 1 and 1/2. Here's 0, 1. Here's 1, 2. And here's 2, 4. I'm going to graph this with a dashed line because that's not really the graph that I'm doing here. That's the graph of 2 to the x. So if I wanted to graph f of x, which is 2 to the x minus 3 plus 1, what I'm telling you is I could just move these points right 3, up 1. So let's do it. So let's take this point. It is -1 and 0.5. If I moved it right 3, we're not going to be able to move all of them, by the way. It would go right there and up 1. What are the coordinates of that point? Two and 1.5. All right, let's at least just do 2 more points, see if we can fit them on there. Let's take this point. The coordinates of this point are 0, 1. We're going to move them right 3 and up 1, and they're going to go to the point that's 3, 2. This is the point 1, 2. If I moved it right 3, I know it's going to go off the grid a little bit. We can do that. Up 1, that goes to the point 4, 3. And then I sketch my new graph. Okay. So yesterday we talked a little bit about domain and range, and we said for all exponential functions the domain is all real numbers. Did I do that with the R in here? Okay. And I said the range, let's look at the purple graph. The range of the purple graph is 0 to infinity, but now I moved it right. That doesn't change anything about the range. But +1 does. Instead of 0 to infinity, what would the range of this be? What doesn't go below? Just give me an indicator, you know. Okay? It doesn't go below 1. So this would be 1 to infinity. Okay, so that's something where we have transformations of both things. I think we discuss this yesterday? Do you need to do that example? If I did just +1, I think we can all do that one. Let's go to this graph over here. So what about if I had the function -2 to the x instead of 2 to the x? What essentially happens is, I'll show you. Doing the original graph here, okay? I just did these points, agreed? We said -1 was 1/2, 0 was 1, 1 was 2, and 2 was 4. So if I told you, all right guys, instead of the output being 2 to the x, I want you to make the output the opposite of 2 to the x. What would happen to all of these values? Yes, they would just be flipped. They would be negative. So this instead would go to -1, -1/2, 0, -1, 1, -2, and 2, -4. And what I want to just show you is what that looks like on the graph. So if I plotted those points, it would just be everything instead of up here would be down below the x-axis. So there's -1, -1/2, 0, -1. Oh, scale, comma ray scale. What is the scale going by? 2's, sorry. -1, -1/2 would then be right about here. 0, -1, if this is going by 2, would be like right here. And then 1, -2 would be like right here. All right. So that is an exponential graph, just flipped upside down. Okay. So just kind of looking at picking apart things in the equation and then how it affects the graph. here's the deal. At this point, you have the aid of a graphing calculator or Desmos. So, use that as a guide, but you should, in your head, like, start to be thinking about, hey, what does this do to the graph? It shouldn't just be like a surprise when you pop it in there. Okay, what do I want to talk about for the rest of the time? Yay! Growth with fixed percent, decay with fixed percent. This is probably the thing that's most applicable that you're going to see in life with exponential models. So here's how it works. When we're dealing with, it could be population, it could be the value of something, and it's exponential. What we're going to see here is this A. Remember before it was the y-intercept or initial value? It is still the initial value. So in a second we're going to do population. If it's population, it's the beginning population. If it's the value of something, it's the initial value of that item. When we are growing at a percent, okay? So you'll see it'll say something in the problem like it's growing at a 2% per year or something like that. That in my head tells me this is exponential. To find B, what we're going to do is we're going to add 1 to that percentage. And so R in this case is the rate as a decimal. Do you all know how to convert percentages to decimals? Okay, you divide by 100 or multiply or move the decimal 2 spots to the left. Okay, so here's why. If I said our population in Comstock Park is growing at 5%, is anyone leaving? Well, okay, just maybe, but it's growing at 5%. Is the number of people leaving? No. So you're keeping 100%. That's where this one comes from. You're keeping 100% of your population, plus you're adding a percent on. So that's what that 1 plus R comes from. All right. How about if it's decay with a fixed percent? Well, A is my initial value. Who remembers? What do I do with B this time? Yes, it's 1 minus the rate. And the rate, again, is a decimal. This is like flipped around, okay? So let's say what's something that goes down in value? Car, okay? Let's say I buy a car and I know it goes down 10% a year. I want to know how much the car's worth. If it's going down by 10% a year, how much of its value is it keeping? Sophia? Something goes down by 10 points. 10%. 100% down 10%. What percent is it at now? Right. So what percent is it half? I don't know. You don't know what I'm asking? Kimberly, what do you think? It would be 90%. Yeah. So if something had 100% and it went down 10%, we'd now be at 90% of it. So 100% minus the rate. Okay. All right. Population. Let's try. Let's underline some keywords. First of all, I want to figure out the rate and is it growing or decaying? Would you underline those two things, please? It would be help if I didn't have a typo in that problem. And great. It's great. It should be growing. What's the rate it's growing at? Now, there happens to be a decimal in 1.3. That doesn't mean that it's its decimal, okay? If it's 1.3%, R, move it over 2 spots, is 0.013. Okay, did anybody see what the initial value was? 4.6 million. We don't have to write out the whole million, guys, as long as you understand it's going to give you the population in millions. All right, let's write our equation. Y equals my initial value of 4.6. R is 0.013. What's 1 plus 0.013? It should be 1.013 to the x power. Okay, now typically with population models, what we're dealing with here is x starts at the year it began. What year did this begin? 2010. Okay, so when we're answering this question now, remember, we're not going to put in 2040 for x. We're going to figure out how much time has gone by. All right, we're going to need a calculator for this. If I wanted to find the population, let's say it continues, in 2040, what would I be putting in for x? If this is years since 2010, do it. 30 years. All right, cool. Would you put that in your calculators? It's population, so let's round to the nearest person. I got 6.0, it's million people. Let's just round to 1 decimal. I got about 6.8 million. Is that what you got too? Okay. Let's take a look at this one. This is an example of a decay rate, but this time you're picking out, I'm giving you the equation. I'm asking you if you can figure out what the rate is. Okay, so a factory purchased a 3D printer in 2010. The value of the printer is modeled by this function, where x is the number of years since 1910. Okay, what was the initial value of the printer, by the way? 30. Okay. All right. So first, let's just answer the question, what's the value of the printer after 10 years? So what's 30 times 0.93 to the 10th power? Let's assume it's $30. I don't think that a 3D printer costs $30, but I don't know. They didn't give me any units. I got 14.5. Okay. Next question. If this is its equation, can you identify for me what percent of its value is the printer losing every year? How did I figure out that this is 0.93. This is how I got it. What percent of the value is the printer losing every year? 7%. So 0.93 equals 1 minus what? That's what I'm asking. Okay, and you're right. It's 0.07. I'm just explaining why. Some of you can just do that in your head. Who in their head saw it right away? Okay, all right. That's 7%.